Hello and welcome back to another video of Wise Interactive Learning. In this video, we are going to see what is the differentiation of composite functions. Before that, I'll just try to explain in a second what is composite functions. So plain functions can be stated just like y equals to sine of x or y equals to log of x or anything just as simple as that. But composite function is something like sine of log x, y equals to sine of log x. Then it necessarily becomes a function of function. What it is says of function of function. So basically what we see is like when we have a function like sine of log x, which is just like this, then it is called composite function or composite function. So when you try to differentiate functions such as y equals to sine x, which is this, then you will have dy upon dx is equals to cos of x. It is very straightforward and very simple. In case of log x, you have dy upon dx equals to 1 upon x. But how are you going to differentiate sine of log x? Here all the rules do break, and for such things we have a rule called as the chain rule, which necessarily says that when one link, so suppose this is link 1, you just look at the image and then you have a link 2. I'll just call it L2. So when you have two different links, it is connected, and this connection goes on for L3 with L2, and then L4, L5, and so on and so forth, and a chain is formed. So let's take a composite function which is y equals to sine square of log of x raised to 5 plus 4. Now, we can say that here there are four different functions. One is squaring, one is sine x, one is log x, one is x raised to 5 plus 4. So in this case, they necessarily tell you that do a chain rule, meaning that you have to substitute all the values or all the functions with different variables. For example, we can take u equals to x raised to 5 plus 4. Then we can take v equals to log of u. So basically log of u is nothing but log of u, which is x raised to 5 plus 4. And then again we can take sine of v as t. So here we have sine of whatever in the bracket is, it is necessarily v. So sine of v is equals to t. So at the end what we get is, when we substitute, we get y equals to t squared, isn't it? Now in order to find what is dy upon dx, we need to understand few steps over here. Well, what do we understand is y is function of t, then again t is function of v, then v is function of u, and then u is a function of x. I understand that this method is a bit complicated, but I'm going to show you a wise learning technique which is also called as a box rule, which can get you the answer in one step. So we'll check the traditional method. So y is a function of t, so we have dy upon dt. Then this is done. What is the second? T is function of v, so we have dt upon dv. Then we have v as function of u, dv upon du times du upon dx. So you can see here, like we don't have to cancel it, but dt and dt gets cancelled, dv and dv gets cancelled, du and du gets cancelled, and what we are remaining with is dy upon dx, which was the necessary part in our example. Now in order to understand, we'll just drag it down here. Now what we have is dy upon dt. So y is equals to t square, so dy upon dt is 2 times t. Now what we have is t equals to sine of v, so dt upon dv, we have sine of v. When differentiated, it will give you cos of v. Now du, so what we have is v equals to log of u, so dv upon du will be 1 upon u, and then you have u equals to x raised to 5 plus 4. So you have du upon dx as 5x raised to 4 plus 0, which is nothing but 5x raised to 4. Now you have to multiply all these values. So dy upon dx will be 2 times t, which is 2t times cos of v times 1 upon u times 5x raised to 4. Now you can substitute all the values, but we are going to substitute it very smartly so that we don't have to again do all the reprocessing, which is 2 times t. So t is nothing but sine of v, v is nothing but log of u, and u is nothing but x raised to 5 plus 4. So basically it's the same term in the initial original example, which states as t will be sine of log of x raised to 5 plus 4. Immediately we have the first term. What is cos of u? So cos of v will be, v is nothing but log of u or log of x raised to 5 plus 4. So it will be cos of log of x raised to 5 plus 4. Then we have 1 upon u. So u can be stated as everything divided by x raised to 5 plus 4, since we have the u value over here, right? And then it states 5x raised to 4. So we can simplify this further by I'll just add some space over here. We can say that this 2 and this sine of theta times cos of theta. So it is sine of 2 theta, which is sine 2 times log of x raised to 5 plus 4, and then everything divided by x raised to 5 plus 4 times 5x raised to 4. So this is your answer. And this process is a little bit tiring or a little bit hard to understand. So I'm going to explain you the wise interactive learning technique, which will make it easy to understand for you to easily get the answers within seconds, right? So we'll take an example and we'll just call this as wise learning technique, right? And it is the same thing, but I'm going to explain it in a different manner. So we'll call the black box as B1, right? We'll call the orange box as B2, and we'll call the pink box as B3, right? And now just imagine that you have to open all the boxes on each occasion, but every box is inside the other boxes. Like B2 is inside of B1 and B3 is inside of B2. So in real world, just imagine you have to open 3 boxes. Then how are you going to open them? Well, what you'll do is first you'll open the box 1, or rather B1. So you're going to open B1, then you're going to open B2, then you're going to open B3. Isn't it? So it's very simple. So let's take an example. Y equals to sine of x square plus 9x. Or let's make it more complicated. Sine square x square plus 9x. Sine square x square plus 9x. This is the function. So let's take. So when you go by substituting or the chain rule, it is going to be a little bit problematic for you to get this all the terms. Like you have to put u equals to x square plus 9x, and then again you have to put sine of something, sine of u as t, and then you again have to substitute. Rather, what are we going to do here is very precious for you to understand all the differentiation topic in itself of composite. Like, so what is this box opening has to do with the chain rule? The chain rule, or rather the box opening rule, is the same, but I'm going to explain you in different manner. So when you are going to differentiate any function, consider it as a box from left to right. Now in this case, what are we going to say? Okay, let's take the outermost box. So we can write this as sine of x square plus 9x whole raised to 2 is the same thing, like these two are same, right? So now let's take the outermost box. What is it? It is something raised to 2, and we know that anything raised to 2, its differentiation will be 2x, isn't it? X squared will be 2x. So y is equals to, first box when you open it, it is going to be multiplication after that. So it is 2 times whatever is inside the box, you write as it is, sine of x square plus 9x. Then you multiply and go inside the other box. So first it was the outer function, then you go inside. So first we took the black box b1, then you go inside to do b2, which is sine. So what is differentiation of sine? We have cos of whatever is inside the box, which is x square plus 9x. And then you multiply, and then you again go to the pink box. So what I mean by this is the differentiation of x square plus 9x will be 2x plus 9. So see, in one step we have the answer for this whole example without any substitution. And how we have done it? We have just taken everything, like any function, as boxes. Like you don't have to consider it as two different functions and then go one inside the other. You just consider it as function of function, and then just go on multiplying by the differentiation of each and every function. So we'll take another example and we'll try to solve it. So now we have two functions. First we'll try to solve it with the chain rule or by just substitution, and the second one we'll solve it with the box rule. So this will be with chain, this one will be with box. And if you see that this first function is rather more simpler than this to differentiate, and most of the people are going to have issues with solving the second, but we'll explain the easiest way to do this. So in this case, you are going to replace everything by u. So you have u equals to 5x cube minus 4x square minus 8x, and then you have u raised to 9. So y equals to u raised to 9, and then you again differentiate it with 9. So you have dy upon dx equals to du dy upon du times du upon dx. So you have 9 u raised to 8 times the differentiation of du upon dx will be so you have to differentiate 5x cube minus 4x square minus 8x in one term, which will give you 5 times 3x square minus 4 times 2x minus 8. And in this case we have 9. What is u? U is nothing but the original term, which is 5x cube minus 4x square minus 8x times 15x square minus 8x minus 8. So this is your final answer, and we'll try to partition it. So this is your first way to do it. And if you want to do this example also, like the first example by box rule, we can do it in one step. So dy upon dx, how are we going to do this? So the first box is of 9, so anything raised to 9 will be 9, the whole term as it is, 5x cube minus 4x square minus 8x, and then you go inside. So the first box was anything raised to 9, then again you go inside, then we have this function. So you multiply that by the differentiation of it. So 5x cube will give you 15x square minus 8x minus 8. So there you have it. In one step, you have calculated the whole answer. So we'll go on to the box rule now. We'll try to do everything with box rule. So what will be the first function? The first function will be the outer box, which is square. So dy upon dx, in one method only we are going to have, in one step only we are going to have. So 2, anything raised to power 2 will be 2 of that function, which is sine log of 2x plus 3. Then we go inside, the first function which we have is sine. So when you multiply that by sine, so the differentiation for that will be cos of the whole function as it is. Then again you go inside, so you multiply that by the differentiation of this function, which is log 2x plus 3. So the multiplication will be 1 upon 2x plus 3. And then you have again the inside function is 2x plus 3. So then you multiply it by 2 plus 0, which is nothing but 2. So in the final answer, what you have is, so see, you have this 2 over here. In the denominator, you have 2x plus 3. So you take 2, everything divided by 2x plus 3. And now you'll be shocked to know that why I haven't taken this 2. So we have a formula in trigonometry which says that 2 times of sine of theta plus cos of theta is nothing but sine of 2 theta, which will be sine of 2 times log of 2x plus 3. And that's your final answer. So within one step, or rather within just simplification of the first step will be the second step. It gives you the final answer, which is y dash. And you can say that this rule is far more efficient to understand. And I'm again going to explain this in very split second, just by looking at this particular diagram. So I'll just try to rub this off.